I'm looking here at balancing forces on an object in equilibrium on a slope. I'm using the same forces that I used for my object on a horizontal surface, but I've turned now to an angle. And you can see that although the weight acts still vertically downwards, it doesn't any longer act parallel or perpendicular to the slope. So I have to resolve those into their components. And I did that to show you on one of my previous videos in the playlist. So now I can make an equation for the parallel and an equation for the perpendicular direction. So in the parallel direction, t cos alpha minus friction minus w sine beta going downwards is equal to 0 because there's no acceleration, and again perpendicular r plus t sine alpha minus w cos beta equals 0. So I'm going to put some numbers into that so that I can use it to find some values. So here I have friction is 3 newtons. I've given an angle here and an angle here and a mass to the box, which means that the box 2 multiplied by gravity gives me the weight. So now resolving parallel to the slope, I have t cos 30 going up the slope, and balanced against that on the other side of the equation, 3 and 2 sine 40 going down the slope, which gives me this equation here, and that's equal to 18.0 newtons to 3 significant figures. Now I want to use that value exactly later, so I've put that into my calculator already and calculated that, as you can see, and that's now stored in my answer function. So perpendicular to the slope, I have r plus t sine 30 minus 2g cos 4, or equals 2g cos 40 going downwards. And so rearranging, I get this equation here with my t in it, and instead of using t, I'm going to use my answer for t in the calculator. So without clearing off my calculator, 2 times 9.8 cos 40 minus answer sine 30 equals 6.01 to 3 significant figures.